Alright guys, today we're going to be doing some non-calculator FRQ practice, and this stuff is pretty easy, just all review. And the first question gives you the function g of x, right? And they want you to manipulate your exponents to make it into one singular, just have one base. So we want to combine all of these things together, right? So the first thing that we're going to do is we know that since this is a multiplication, that means that you can just add the exponents together. So the top part will be or before we do that, I should show you this one is just multiplication because it's power to a power. So it'd be e to the 10x times e to the x plus 3, which just equals e to the 11x plus 3. Right? So we got that part. And you know that when it's over a exponent, 1 over e to the 4 is equal to e to the negative 4. And since multiplication and division are pretty much the same, you can just say that's times e to the negative 4. And if we do our addition again, it will just be e to the 11x minus 1. And it wants you in ax plus b format for the exponent, and that's how we just did it, so you can just say that as the answer. Alright, going on to the next question, it wants you to give this as a function with only tangent of x, and you can see that 1 minus secant of x, you know, our Pythagorean identities will just be 1 equals secant squared x minus tangent squared x. So 1 minus secant of x will just equal negative tangent squared x. And we've basically done our whole thing now. We just gotta combine the two together. So that would be negative tan squared x times tangent of x will just be negative tangent cubed x, right? Nice and easy. Okay, so that's first part done, and then the second part, B, gives you another set of functions, and it says to find where this function equals 3 and find all the x values, right? And this one's pretty easy, right? Just solving for log. We have a little bit of log manipulation, but it's like basic, right? So let's see. This one, I believe I just did because it's an addition of two logs. Remember, our log properties say that if you add two logs, you can multiply their insides, and if their bases are same, you can do that, right? So it would just be j of x can be rewritten as equals log base 2 of x plus 5 times x minus 2, right? And it's pretty simple, so we'll just simplify the inside. J of x equals log base 2 of, believe when you multiply that, that's x squared plus 3x. Oh man, I'm rusty. X squared plus 3x minus 10, right? And from there, we just we can do hold on. Once we get that, we can change j of x to 3. So we can do rewrite our log as 2 to the 3 equals x squared plus 3x minus 10, right? I'm going to erase this top part here because we don't need that anymore. So we can rewrite it at that. So that'd be 8 equals x squared plus 3x minus 10, which should just be equals 0x squared plus 3x minus 18. and we can just do our zero product property and factor it out to x plus 6 and x minus 3. And that should give us x equals minus 6 and 3. Nice and easy. See? Not that hard. Bang. Okay. So we've got that first part done. Next part is on the next page. And it says solve k of x equals 0 for all values of x in the interval 0 to 2 pi. And if we go back, that is this function, right? So what do we want to find? Where it equals 0. Okay. So redo this. So it's 0 equals 2 sine x cosine x plus sine of x. And I believed I did this one by doing okay, well, let's think about this for a second. 2 times sine of x cosine of x is just another way of saying sine of 2x plus sine of x, right? So this should equal 0. So logically, these two should cancel each other out, right? And let's think about what number between 0 and 2 pi inclusive, what number, or I don't think we include 2 pi, what number between there will give us things that one of them is positive, one of them is a negative, right? But when you times one of those by 2, then it will give you like the negative opposite of it. I don't know if what I'm saying makes sense, but the way I thought of it was that they should obviously cancel each other out. So it should be x equals 2 pi over 3, right? And that's only one answer. I'm pretty sure there's another one, but I haven't checked yet. But basically, sine of 2x. So when you multiply this by 2, 4 pi over 3, you get, you should get, sine of 4 pi over 3 is negative root 3 over 2. Yeah, negative equals negative root 3 over 2 when you sine this, right? But when you sine just x, 2 pi over 3, you should get root 3 over 2. And obviously, when you add negative root 3 over 2 and regular root 3 over 2, you should get 0, right? So that's how I found this answer, x equals 2 pi over 3. I'm sure there's a better way of solving it, but that's the way I solved it. And there is, I believe there's another answer, but I'm kind of too lazy to look for it. But the other answer will be like a, it will be an x value that's bigger than pi, but less than 2 pi, I'm sure. Because when you times that by 2, should get 1 down here, 1 up there, and they'll cancel out. So this is just one of the answers. The other answer, I'm pretty sure, will be like 4 pi over 3 or something. Or not 4 pi over 3. It will be like 8 pi over 3. Oh, no, yeah, the other answer is 4 pi over 3. And I'm sure there's, like, a couple more, but those are the two I could find for now. And moving on to C, function m is given by, God, that didn't transfer over well, did it? No. Okay, so function m is given by this, right? And it wants you to find all input values in the domain of this function that would yield an output of -3. It's just a fancy way of saying find x when this equals 3, right? It's pretty simple. And what we can do here is, one's kind of a pain in the ass to solve, but, or sorry, -3. You can do, let's just set it up first where, I'm actually going to go to this separate page and do it because I'm going to need a little bit more room. But we can do -3 equals ln, it was like this, ln of 2x all this squared minus 4 times ln of 2x, right? And that we can further put that out to be negative 3 equals ln of 2x times ln of 2x times, or not times, I'm sorry, minus 4 ln of 2x. And we're seeing a common recurring theme of the ln of 2x, right? But, yeah, so, oh, no, I should actually keep that a quadratic, I think, maybe. That might work out better. So, ln of 2x, squared, minus 4 ln of 2x, plus 3 equals 0. And you see it's just a quadratic, right? Pretty, we know this stuff. So it's 0 equals, if we factor it, it should be, I think it will be ln of 2x minus 3. I don't know if the numbers I'm using are completely right. Oh no, hold on, it shouldn't be like that. ln of 2x minus 3, but the way I'm solving it is right. So even if my answers are wrong, I did solve it using the right method. So that's all you guys need to know for the test. And we should get 0 equals, or not 0, I'm sorry, ln of 2x will either equal 3 or ln of 2x will equal 1, right? And just knowing that ln is log base e, we can do e to the 3 equals 2x, or e to the 1 equals 2x, which makes it simple to just be x equals e cubed over 2, or x equals e over 2, right? Nice and simple. So all we really did there was make it a quadratic, and then just factor it out, and then just find it like a normal quadratic, right? So on to number 4. All right, number 4. Let's do this one pretty quickly because I want to go eat lunch. Let's see. The functions g and h are given by these two. Number 1 wants us to solve for g of x equals 1, values of x in the domain of g. So we actually did like the similar problem before, remember? But this time, it's just different numbers and like a different format, I guess. So g of x equals 1, so 1 equals 8 to the x times 8 to the 2x over 8 to the 5, right? And this one's super easy to do. I'm not even joking, like 8 to the 5, because we multiply this over there. 8 to the 5 equals 8 to the 3x, because we know that we can just add these two because it's a multiplication, right? And since the bases are same, we can just do 5 equals 3x, and x equals 5 over 3. Bang. Super easy, super simple. No sweat. Okay, now question 2 wants us to look for h of x equals 2 for domains of x in h. Values of x in the domain of h, I'm sorry. So that just means, yeah, find for x. Okay. So we can do, I'm going to erase all this because you guys don't need it anymore. We're going to do, what's it, 2? Yeah, 2 equals log base 4 of x plus log base 4 of 5. I believe that's right. I think. So anyways, we're gonna we're gonna do 2 equals log base 4 of 5x, because we know our log properties will let us multiply these inside things if it's addition and the base is the same. So 4 to the 2 equals 5x. So 4 to the 2. I'm sorry, 2 to the 4. I mean, they're equals the same thing anyway, so it doesn't matter. But 2 to the 4 equals 16 equals 5x. X should equal 16 over 5. Bang, okay. On to the next one. We're almost there, guys. Now, this one is kind of really annoying to do. It actually took me a while to figure this one out, but I think I've done it right. So 4b1, I'm going to make an extra page because this one is kind of long. So 4b1, rewrite j of x as a fraction involving powers of sine of x and no other trigonomic function. So just rewrite it as just sine. So we write it over here as 10 squared x for secant squared x over cosecant x. Okay, so the way I did this one was, first we know that tan of x is sine of x squared. Oh lord, that looks horrible. It's sine squared x over cosine squared x times 1 over cosine squared x times cosecant, when it's in the denominator, should equal sine of x over 1. So we really just get sine cubed x, that's a horrible 3, sine cubed x over cosine 4x, which can be also just written as sine cubed x over cosine squared x over 2. And we only want sine, right? So what we can just do is sine cubed x over 1 minus sine squared x squared. That's literally all we have to do. It took me like an hour to figure this one out, but we can, I forgot that you can do that and split it up into cosine squared x squared, and you can just from there put it into this, and you can just leave it like this. You don't have to FOIL it out and like make it look good, because it just asks you to put it in only sine form, right? And you've done what they ask you to do, so that's all you really need to do there. So that's your answer. I'm gonna erase this now. Okay, next one asks you to write the bottom one, k of x, as expression using only cosine and nothing else. And this one's actually pretty easy. This one is k of x equals sine 2x times sine of x, right? And well, we know that sine of 2x is just 2 sine of x cosine of x times sine of x, which is just 2 sine of x, 2 sine squared x times cosine x. And we know we're using our trig identities. This is just 1 minus cosine squared x times cosine of x equals k of x. What of x? Okay, see, and that's your answer, because they just want it in cosine. You don't have to multiply this out, blah, blah, blah. Don't have to do any of that junk, because it's not what they ask for. And if you do it like that, you might end up getting it wrong, and you might get the question wrong, which would suck, because you tried to go extra and you just messed up. Anyway, so that's your answer for that one. And for the next one, we have C, for C, we want to find everything in here. Okay, so just ask you to solve for x when this equals 3 over 2. And this one's actually, I don't like this question, but because it takes a lot of work and I'm too lazy to do this, but you're going to need to know it for the test, so I guess you do it, I guess. So it asks you to find when the outputs are 3 over 2, find the inputs. So that just means find x, right? So that's cosine of x plus pi over 3 minus sine of x plus pi over 6. And you'll see that we know our trig addition, or hopefully we do, and we know that this just equals cosine of x cosine of pi over 3 minus sine of x sine of pi over 3, right? Put all that in parentheses, and we'll subtract gotta squeeze this in, sine of x cosine of pi over 6 plus cosine of x sine of pi over right? And that looks really scary and intimidating, but it's really not, because we can simplify these to be just, I'm going to do it in my head, but you don't have to do it in your head. You could probably better to write it out so you don't mess up, but don't really care that much right now, so, over 2, probably don't need a parentheses there, over 2 minus, root 3 over 2 sine of x, minus root 3 sine of x over 2 minus, God, it's cosine x over 2, I think. Okay, yeah, I'm pretty sure that's right. Yeah, I think that's right. Okay, so we can see here that we can automatically just cancel, oh crap. We can cancel these out, right? So we only have these two left, equals that. So 3 over 2 equals negative 2 root 3 sine of x over 2. These two cancel out, which equals 3 over 2 equals negative root 3 sine of x, which will equal negative 3 over 2 root 3 equals sine of x. And you're wondering, oh crap, there's nothing that no function that looks like this. And you'd actually be right, but you're actually wrong too at the same time, because we can rationalize this to make we can rationalize this to make this something we know, right? So we times this whole thing by root 3 over 3. We times it by this, because that's how you rationalize, right? So that'd be negative 3 root 3 over 2 times 3. And we can cancel these out to equal negative root 3 over 2 equals sine of x. And from here, you know this, x equals 4 pi over 3 and 5 pi over 3, right? Nice and easy. So it's, this one was kind of a pain in the butt because it's long and I hate it, but it's not that hard to do. So you guys should be fine. And, there's, like, other things you guys need me to do, just tell me.